Hi everyone, today's lesson is starting a new unit called Area and Volumes of Solids. So what I want to ask you first before we start this lesson is basically if you could name any of these shapes. So if you were naming this shape right here, would you guess that that's a sphere? Or this shape right here, would you think that that's a cone? And this shape right here, what is that? And this would be a square-based pyramid. See how it goes like that? So that would be a square pyramid. This right here, going down on both sides, that's a cylinder. And this right here is a square prism. This is a square pyramid. This is a square prism. And so today what we're going to be covering is shapes that are solids that are basically prisms. So today's all about prisms. And just to clarify, prisms are shapes that are solids that when you're looking at this like this, you see that it has the same base on the top and the bottom. That's a prism. Then you have parts that go around it. And so these solids right here, this would be a prism, where this shape right here would not be a prism. This would be a pyramid. See how it comes to a point and it doesn't have the same base. It's got a square base. So this is actually called a square prism, but this right here could be called a rectangular prism. Okay, it's got a base and a base that are exactly the same. This right here, this is called a square prism. It's called a square prism because the base is the same. And another name of calling this square prism is a cube. Anything that has the same base, top and bottom. So this right here, count the sides. This is a 1, 2, 3, 4, 5, 6. That's a hexagon. So that means that this right here that has a base on the top and the bottom that are the same, that would be a hexagonal prism. Hexagonal, you name it, this solid is named by the base. So that's a hexagonal and it's a prism. This shape right here, if you count the sides, this is an octagon. So that's an octagonal prism. And let's see here, we got a couple more. This is also a square prism or a rectangular prism, a square prism would look like this. But basically you're looking at the base. Now this doesn't have to be the base. You could have this being the base, and that's a rectangle. So you can call that a rectangular prism. This right here, I'm going to call this a triangle. See how the triangle on both sides, we call that a triangular prism because the bases are both the same. Okay, so let's move on. So today we're going to actually focus on just prisms. This shape right here, a triangular prism. This could be a square or rectangular prism. 1, 2, 3, 4, 5. That's a pentagonal prism. So the solids are named basically based on their bases. This is a hexagonal prism because I have 6 sides. 8 sides, octagonal prism, and I'm not sure how many that has. So introduction to solids and prisms. So today you are going to be getting some nets. Nets are basically taking your prism and laying it out and then trying to discover formulas and areas and that kind of thing. You're going to classify the solids just like we were talking about. We're going to talk about faces, edges, and vertices. We're going to talk about bases and lateral faces. So basically, just a heads up, a base in a prism, you have a base and a base. The bases are the two of the same thing. Whereas you have lateral faces, lateral meaning around, okay? So this would be a lateral face. This would be a lateral face. That would be a lateral face, okay? All right, the total area, we're going to sketch some solids, etc. So if I'm looking at this prism, it's a prism because this base right here, okay, and this base up on top are matching. So that, I'm going to say this is a square, so this is a square prism, all right? how many faces do I have? Now, how many bases do I have? How many faces? So I have one base here, one base here. That means my faces would be around. So that'd be a lateral, round, around, around, and around. Okay. Your edges look like this. These are edges, the corners. Those are your edges. All right. Now you can have edges going up and down, but you can also have edges going across. We call those base edges. Okay. Those are base edges. This is a lateral edge. So this is a lateral edge. And my vertices are these little corners. See where the two prisms get together? The two shapes get together here. So those are all my vertices. This right here is a base edge, 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 which basically means this is my base and this is my base. So those are base edges. So again, a face is this in front. That's a face. Okay. These going around are called lateral faces. Okay. Important note is that bases don't have to be on the bottom, of course. But I do need you to understand something. If this is a prism, your bases have to match. So basically, if you look around this prism, you've got a rectangle here, right? A rectangle here, oh, another rectangle. See how a rectangle's all the way around? What that means is if those are all rectangles going all the way around, what that's telling you is that my base edges or my two bases are here. Let me show you where they're at. Okay, highlighter. So here's one of my bases right here in the front. See that? That in front is my base. And it's my base because remember, I have to have two of the same thing. So the base in the back, that would also be a base that's going around like that. So that base and the front base. Okay, let me erase this part to see if I can show you that a little bit more clear. A base in the back, that's a base. A base in the front, okay? That means that this is because I have 5 sides, we call this a pentagonal prism. So this right here, because of the base is a pentagon, we call this a pentagonal prism. All right. Now, here's each of you are going to get a set of nets, and what these nets are you're basically they're a solid of some shape, and they're all going to be different. Each student is going to get a net. You're going to be working with a partner. When you get the net, before you cut it out, I want you to make a prediction about what kind of solid you think it's going to be. Then cut along the solid lines, not the dotted, the solid lines, and then you're going to put the solid together. Do not tape the solid. You're going to do, you will do this at the very end of the poster. So you will be getting a poster. Your poster will look something like this. This is the poster right here, okay? And that's going to be passed out to you. And so what's going to happen is this. You're going to get your net. You're going to tell me how many bases it has. Remember, if it's a prism, it has to have 2 bases. And then you're going to say, how many lateral faces does it have? You're going to find the total area. Remember, the area is going to be, the total area is the area all the way around the shape, plus the bottom and the top. You're going to sketch it. And then lastly, you're going to tell me the faces, the edges, and the vertices. Okay? You're going to create a poster for this. And because each student is going to get one of these posters, you're going to work together with somebody else, and you're each going to get 2 solids that you have to figure out what they are. So after you're done with that activity, we're going to get back into the video. So you watch the video, start watching the video, pause, do your netting, and then we're going to get back into this. And so what we're doing is right now we're talking about different kinds of prisms. This is a prism right here. We call it a right prism. A right prism does have a right angle here. And it means that it's straight up and down. Like this is a right prism. This shape right here is a right prism. this right here is a right prism because they're straight up and down, they're perpendicular with the base. Now, to be a prism, the shape has to have a few characteristics. First of all, a prism has to have two faces that are identical in shape, and they have to be parallel. So that means that this side here is parallel to this side. That makes those my bases, okay? The two faces are sometimes called the bases. I call them the bases all the time. Between these two faces, there's the rest of the sides of the prism, and those are the sides that go around. We call those the lateral faces, okay? Okay, so a little bit of vocabulary. So the base, we have a base. Now remember, a base is this shape down here on the bottom, this shape right here. But at the same time, you have two bases, and they have to be parallel. So there's another base right there. A lateral face, okay, so a lateral face, there's lateral face, looks like this. That's a lateral face here, here, going all the way around. Lateral face, like that. Now, a base edge is going to look like this. There's an edge, and that's a base. See that edge? That's a base edge right there. Base edge, okay? And additionally, you have base edges up on the top as well. Now, you've got lateral edges. See this right here? These are lateral edges because they're going around the side. Going around the side is lateral. So if I'm looking at this shape right here, okay, this right here is a rectangular prism. I'm looking at these two bases here that are the same. This shape here, that's a corner. We call that a lateral edge. It's lateral because it goes around the side. Lateral edge, lateral edge, lateral edge, lateral edge. Base edge, base edge, base edge, okay? And then you have the altitude. Now the altitude is very important. The altitude is always perpendicular, okay? Now I could put my altitude right in the middle like that. It still needs to be perpendicular. That's basically the altitude is my height. Okay, so let's say my height is 10 centimeters. So that's the length that separates the two bases. Now for this shape right here, see there's a base right here, and here's another base right here. Now see how my bases are the same? Those are both triangles. That's called a triangular prism. Triangular prism. It's called a triangular prism because my bases are the same, they're parallel, okay? That would mean then that this length right here, or this length that goes from here, this inside here to here, that's my height. Remember, my height is perpendicular. Now, I want to go back real quick because I didn't talk about this right here, which is not a right prism. Those we call oblique. Okay, and I know that word's not on here, but that's what they're called, oblique. They're a prism that's sort of tilted. So that's like an oblique prism, so it's tilted. All right. Again, you have lateral edges, so lateral edge, lateral edge, lateral edge, and this side, base edge, base edge, base edge, base edge, base edge, and base edge. Now, the difference between lateral area and total surface area, okay, we either call it total area or surface area. The lateral area, remember, just like the sides that are lateral, the lateral area is the area of all the sides. So a lot of people will find if your job is to find the area, that space that it encompasses, the lateral area, they're going to find the area of all these sides right here, which are all the same if it's a regular prism. And they're going to multiply that area, okay, by how many ever sides they have. But total surface area is different than lateral area. Lateral area, again, sides. Total surface area is the lateral area, which is the sides, plus the two bases. So we've got this base here and this base here. So basically, if I want the total surface area, I'm going to find the area of all the sides going around plus the area of the two sides, top and bottom, which are my bases. Now, we do have a formula for lateral area. So the lateral area is basically the perimeter of one base, times the height of the prism. Now, if you don't know what this prism is a 1, 2, 3, 4, 5, 6. We call this a hexagonal prism. It's a prism because the bases, when I flip these up, are the same. And so that shape actually, let's see here, I'm just going to start with that right here. This shape right here, when I make these go around, right, going like this, okay, those shapes going down like this. Let's see here, 1, 2, 3, 4, 5, 6. So sort of like that. And so that is a hexagonal prism. So in order to find the lateral area, some people are going to find this area for each of these, and they're going to find the rectangular areas, and they're going to add them all up, right? They're going to find one rectangular area, and in this case, it's up though. So let me fix that. So it looks like this. I'm going to find the area, base times height, length times width, etc. And then I'm going to multiply that by 6 times the area of that shape. And so what that's going to do is give me the lateral area, which is the area going around. However, my formula, perimeter times height. So I'm going to find the perimeter of one of these sides. Let's say this is 4 centimeters. So that's going to be 4 times 6 sides, which is 24 centimeters. And then I'm going to multiply that by the height. And let's say my height is 2 centimeters. So I'm going to go 24 centimeters times 2 centimeters. So that's going to be perimeter times height. So my perimeter was 24 centimeters times my height, which is 2 centimeters. And so the lateral area is going to be 48 centimeters squared. And just a note, remember, area is always centimeters squared or units squared. So if you're finding the area or the total area, your answers are always going to be squared. Now, what we're going to talk about in the next portion of this is actually volume of a prism. Now, the volume of a prism has a really cool formula that we want to remember. It's BH. Capital BH. Capital B, write this down, stands for the area of one base. That's a capital B. Okay, that's what that means. So let me move this over here. So the capital B, okay, stands for the area of one base. So the area of one base is my capital B. The H stands for the height of my shape. So I'm going to find the area of one base times the height, and that's the volume. Now volume, okay, if you don't know the volume is basically filling this solid up. It's all that space inside the three-dimensional figure. So if I took sand and I filled this up, okay, that would be the volume, is filling this up completely, okay? Whereas the difference between volume is all that space that makes this shape. It's a prism, right? It's all that, if I were to just pour sand or dirt all the way inside of this, that would be the volume, the amount of space that fills up. Whereas area is just an area of a two-dimensional shape, whereas volume is three-dimensional, okay? So we're going to practice this, okay? Find the volume, we're going to do that, the lateral area, and the total surface area of a rectangular solid below. So this is the solid we're going to look at. And I redrew this right here because I wanted you to see that this shape is this shape right here. You see how the bases are the same? We've got two little squares here. So I could call this a rectangular prism or rectangular solid. However, I could also see the bases have to be the same. So these two bases are the same. And because it's not a square, I mean, and if you look in the shape in the slide, you'll see that this is 4 and 5. So it's not a square. So that's why it's called a rectangular prism. But you'll see This one actually is a square, but anyway. So this is laying down like that. All I did was move it up like that, okay? And I just wanted you to see that you can either have your solid down like this or up like this, right? Remember that bases don't have to be on the bottom. So in order to find, we're going to find the lateral area first. Now, again, you guys have choices. In order to find the lateral area, which we call LA, okay, you can find the area of all these rectangles, okay? You can find the area of all the rectangles around the sides, and then you can add those all up. That's going to give you the area going around. It's the same thing as this. If you were to find the area of all these little rectangles, right, going around, that's going to give you the lateral area. But remember that we actually have a formula for that. And the formula for the lateral area, okay, the formula for lateral area is the perimeter times the height. Now remember, this value, 12, is my height. So if I were to take this solid and I was to stand it up like that, that's the height. So the perimeter is this. The perimeter is the perimeter of one base. So this is the perimeter of one base. And we're not going to make that capital because capital B means area. So the perimeter of one base times the height of that shape. So we're going to go, this is 4 plus 4, which is 8. 5 and 5, which is 10. 10 plus 8, 18. So the lateral area is going to be 18 times my height, which is 12. Okay, so what you're going to do is you're going to take 18 times 12, and I think calculators are okay. You've got 8 times 1, 8, plus 1, 9. You've got 2, you've got 1, 6, 11, 2, 16. So this is going to be the perimeter, which is 18 units or meters, times the height, which is 12 meters. So that's going to give you 216 meters squared. So that's your lateral area. Now, you now have to find the total area. Now, the total area is your lateral area, which is all this area all the way around, right? Plus, you have to find the area of both the bases, because remember, lateral area is to find the area going around. So you're finding the area of all of that. Whereas total area is the area going around, which is your lateral area, plus the area of both of my bases. So because capital B is the area of one base, we're going to go 2 bases. So this is the formula for total area. It's the lateral area going all the way around plus the area of both bases. So the lateral area, we already know, is 216. So the total area is going to be 216 meters squared plus 2 times the area of one base. I can't see my bases now. It looks like my bases are 4 and 5. So this area is 20, okay? So 2 times 20, length times width, okay? So that's going to be what, 40? So I have 260 meters squared plus 40 meters squared makes 256 meters squared. And so that's my total area. All right. Now, in order to find my volume, remember, that's capital B times H. If it's a prism, the volume of any prism is capital B times H. And capital B stands for the area of one base. Now remember, don't get that confused with the little p, which is the perimeter of one base. But this is the area of one base. So capital B, the area of one base is 20. So that's going to be 20 units times my height, which is 12. So 20 times 12. So 20 units times 12. Well, this was area for 20 is actually 4 units. 4 units times 5 units times 12 units. And that's going to be the area of one base, which is 4 times 5 times 12. So this is 20 times 12. So this is actually becomes, that actually becomes units cubed. So units times units times units is units cubed. So 20 times 12 is 240 units cubed. And so this is the volume of my shape. Okay. So your job for this problem is to find the lateral area and the volume. Now remember, the lateral area is equal to the perimeter times the height. So the perimeter of one base. So I need to find the perimeter of this. So this is going to be 7. This looks like 5. So this is 5. And I'm going to assume that they didn't give me that information. That's also 5. That's 4. So we've got 5 plus 5, which is 10. We have 7 plus 3, which is another 10, plus 4. So that's 24 is my perimeter times my height. The height of my shape is 13. So 24 times 13. So you're going to go 24 times 13, 12, 7, 4, 2. So 2, 3, 12. So your lateral area is 312 units squared, or in this case, it's meters squared because of the m's. So we have 312 meters squared, and that's my lateral area. Now, in order to find the volume, now that's a little bit more tricky. The volume is the area of one base times the height, and this is the volume of a prism. Now remember, prisms and pyramids are different, okay? And in the cases, one of the cases is that, see there, right there, that's a square prism or square pyramid, only one base, whereas any prism has 2 bases. All right, so what we're gonna do is, in order to find the area of one base, remember, area of one base is the capital B. And so the area of one base, you need to look at the base and go, what kind of a base do I have? The base that we have is a trapezoid. And so what that means is because that's a trapezoid, this base is going to be changing for every single shape. Okay, because remember the previous shape that we had, the previous shape was a rectangle. And so therefore the area of that base was base times height. Whereas in this problem, the area of the base is a trapezoid. So we're going to go height divided by 2 times the sum of the bases, base 1 plus base 2, times h. Now this h right here is different than this h here. This height divided by 2 here, this h, they're talking about this h, which is part of, that's my height. That's part of my trapezoid. See this being my trapezoidal area, okay? And so the other h, which is this h here, that h goes to this right here, which is the 13, because that's the height of the whole shape. So that's times h, which is the height, okay? So that's 13. So when we're doing this, we're going to have the height divided by 2. So that's going to be, I'm going to leave this all in little brackets so it'll be easier to work out. 3 divided by 2 times the sum of the bases. So that's going to be 7 plus 4. And times the height of the whole shape, which is 13. Okay, so you're going to go 7 plus 4, which is 11. All right, and you're just going to multiply all of this out. So basically, what you're going to do is you're going to have 11. So I'm going to do this on the calculator. 11 times 3 times 13, and that's 429. So this equals 429 divided by 2. I didn't cancel that 2 out with anything because you have to definitely not this. So 429 divided by 2 is approximately 214. So it's about 214 plus 0.5. So it's it's equal to 214.5. So this is my volume. And so this is units cubed because it's units times units times units, which is the height. So you got to remember, anytime you're talking about volume, it's units cubed. Units cubed. Anytime you're talking about area, whether it's the lateral area or the surface area, you're always talking about units squared, not units cubed. So for this problem right here, this is called a triangular prism. So this one kind of looks like this. It's laying down on the side like that. It's a triangular prism because remember, the bases are the same. And then these are my lateral faces. These are my lateral edges like that. And then, so there we go. It's just laying down on the side, okay? So to find the surface area, I need to find the lateral area first. So the lateral area is the perimeter of one base. So the perimeter of one base, and so that's my P. So P times H times the height of the shape, okay? So the perimeter of one base. Now this is a little bit tricky, right? Because let me make this a little bit bigger, this shape. And the reason why it's slightly tricky is because for me to find the perimeter, all I have is 8, and I don't have the lengths of my sides. So for me to find the perimeter, I have to add up all the sides around, okay? So the perimeter of one base is what I'm working on right now. So I know that this, though, is, if this is isosceles, that means that this comes down at an altitude, and that cuts my base into 2 equal parts, which now makes that a 4 right here. And this also is going to be a 4 to make the 8. Then I see that this is 3. My height is 3, which tells me that this is a 3, 4, 5 right triangle. Remember, it's one of our triplets, so we've got a 3, 4, 5, which means that my perimeter is going to be 8 plus 5 plus 5. So that's going to be 18 units times the height, which is times 3. Okay, so 18 times 3. So we're trying to find the lateral area is going to be 54 units squared. So that's my lateral area. Now, they didn't ask me for the lateral area, right? They asked me for the surface area. But in order to find the surface area, I need the lateral area. Because remember, the surface area, which is all the surfaces. So remember, some people call it surface area. Some people call it total area. But basically, surface area is the area of all the sides, the tops, the bottoms, all the sides, nothing inside, because the inside space is volume, but the outside space is the area. So the surface area is going to be my lateral area plus I have 2 bases. So I need to add those 2 bases in. So 2 times capital B. Remember, the capital B is the area of one base, okay? So my surface area is my lateral area, which is 54 units squared, plus 2 times the area of one base. Now remember, my base area is going to change for every prism. So if you're looking at this prism, and you're like, well, what's the area of this base? Well, this is a triangle. So the area of a triangle is 1/2 the base times the height, but restrictions for this, for any triangle, is that the base and the height are perpendicular. So that when I work this out and I say, well, this is going to be 54 plus 2 times 1/2 my base. Well, I know my base is 8 and my height is 3, okay? And so I'm just going to multiply all this together. So I know my 2's are going to cancel, and I have 8 times 3, which is 24. So what I get is 54 plus 24, and that's 78 units squared, and this is surface area. So that's my surface area. Okay, lastly, they're asking me for my volume, and this is a prism, remember? And so the volume of my prism is equal to capital B times H, and the capital B is the area of one base. We just figured that out. This is the area of one base right here. Now that's not actually 24 because I canceled out the 2's. You got to be careful on that. The area of one base is 8 times 3, 24, divided by 2, which is 12. So the volume is going to be 12 times the height of my whole shape, which is another 12 centimeters. And so that's going to be base times, so I've got base times height of the whole shape. So that's units times units times units, which is 144 units cubed, and that's the volume of my prism. And this prism is called a triangular prism. And because, again, the reason why it's called a triangular prism is because you're looking at the bases. You always look at the bases to name your prism. So this one right here, it's a pentagonal prism. This is a pentagonal prism because, again, my bases are parallel, right? They're the same two shapes. See that? And so that's a pentagonal prism. So what we're going to do is we're just going to find the volume of this. So for the volume of this prism, okay, the volume of any prism is going to be the area of one base times the height. So the area of one base. Now remember, this is a regular polygon. I know it doesn't say that. I'm telling you it's regular. So I'm going to put the regular here. Okay, so this is a regular pentagonal prism. So in order to find the area of a regular polygon, remember the area of one base is 1/2 ANS. The apothem, remember the A, apothem, times the number of sides, times the length of one side. And then this is times H. This is H here. This is that H. That H is that H right there, okay? And so we've got the apothem, which is this value here, times the number of sides, which is 1, 2, 3, 4, 5, times the length of one side. So let's see what we got. So we got 1/2 my apothem. I don't know what that is. The number of sides, I have 5. The length of one side is 6. And my height of my shape is 10. And so I've got this whole part here is the area of my polygon. So in order to find my apothem, I'm actually going to need to do a little bit of trigonometry. So I'm going to cut this like that and put in a radius for my apothem. And if this is a regular polygon, that makes this length here 3. Now, remember, in a pentagon, you've got 180 times n minus 2 is going to give me the sum of the angles in a polygon, right? The sum of the angles. And so because this is a pentagon, we've got 5 minus 2, which is 3. 180 times 3 is 540 degrees. If I were to divide that by 5, I'm going to get each of these angles is 108. Same down here, 108, 108, 108. But when I cut that in half, that makes this little angle in here 54. Okay? So for me to find A, I'm going to use tangent. And so I'm going to go tangent of 54 degrees, remember that's this little corner there, is equal to my apothem over opposite over adjacent, so A over 3. And so A, my apothem, is going to equal 3 times tangent of 54. So I'm going to use my calculator and find tangent of 54. Remember, make sure you're in degrees. So we got tangent of 54 degrees, and then I'm going to multiply that by 3. And times 3. Let's see. Approximate my answer. Looks like it's 4.1. So my apothem is approximately 4.1. So that means that goes right here at 4.1. And now all I have to do now is multiply across. Now, of course, see this 2 here? I can divide that 2 into any one number. So I'm just going to pick dividing 2 into 6, which is 3. So now what I have is 4.1 times 5 times 3 times 10, and that's going to give me 615. So my volume for my prism, and remember this prism is a pentagonal prism. So the volume is going to equal 615 units cubed. All right? Okay. So, well, that's all we have for today for prism. And so I hope that helped. And the next lesson is going to be on pyramids. So I hope you watch that. Thank you.